Welcome everyone to EA Global Summit 2021. This is Juhi from EA Global Summit organizing team. Firstly, thanks to everyone for your interest and for joining us in this session. This session is by Vish, Managing Principal, and Uday Bhatt from CCNC Solutions, Australia. Presenting this session about eHealth, a conceptual framework using microservices architecture and Sparx EA ecosystem. Kindly note that we will be muting all the participants throughout the session, and if any one of you are having any queries during and after the session, please use the chat window or questions window to drop your questions to the speaker. We will be reading out the questions and the speaker will answer during the Q&A session at the end. To enable collaboration and communication with Vish and Uday, and also with other EA practitioners after the session, we request you to visit the dedicated channel for the session in the Microsoft Teams. The link to the Microsoft Teams channel is posted in the chat window for your quick reference. If anyone is having difficulty in connecting to Teams, please reach us in the chat window or write to us at registrations@eaglobalsummit.com. Thanks once again for your interest and support to EA Global Summit 2021. Looking forward to another informative session with Vish and Uday in this year's summit. Over to you, Uday, now.
So, Vish.
Yeah, okay. Hello, everyone. Good morning, good afternoon, or good day, wherever you are. This is a presentation on eHealth. It's a conceptual implementable framework and using, of course, microservices architecture and also primarily Sparx EA ecosystem. I'm the managing principal of CCNC Solutions. CCNC stands for Connectivity, Communication, Collaboration. As it was introduced, we are headquartered in Sydney, Australia, and we'll have a brief introduction about ourselves later on. My colleague and expert enterprise architect, Uday Bhatt, has implemented enterprise architecture and systems in several countries, in several industries, and primarily in the health industry and finance industry. And he will be presenting details of how we can adopt the health architecture. And as an example, to show using Sparx, we use Sparx very widely. As you know, it's a versatile, comprehensive, and most importantly, cost-effective EA tool. So this is actually an attempt to show how this architecture can be developed from top down, starting from capabilities all the way to the solution design. And along the way, there will be some models shown, which are produced by Sparx EA. Next slide. Okay, so who are we to start with? Just as a very brief introduction to ourselves. As I said, CCNC is located in headquartered in Sydney, Australia, but we have a footprint all over the world. And we are actually architecture specialists. In fact, we live and breathe architecture and strategy. To explain our position very simply, we fit in the middle space between strategy and execution. As you know that several strategic consultants like McKinsey and others can produce nice strategy blueprint, and there are hundreds and hundreds of companies, including several hundreds from India, who are ready to implement. But who fills up the middle space? What happens? Who actually links strategy to execution? Most times it falls as a challenge to the organizations, whether it's a bank or a financial institution or a health company. It's a challenge for them. They don't have the resources. They are busy in their own primary area of focus, which is banking or health, and they have to spend a lot of time to understand the complex area of architecture. So that's where we fit in. We hold their hands, we train them, we certify them, we work with them till they become self-sufficient. Next one. Next slide. So just to simply put, again, to introduce a bit more about ourselves, we have a lot of tier 1 clients, like several banks and financial institutions, health institutions. And our primary area in the area of health for the last several years, over 5 years, we are working with a group called AHIN, which is the Asian eHealth Information Network, which comprises of several countries in Asia, over 16 to 18 countries, starting from Sri Lanka to Bangladesh to Malaysia, to Philippines, to Mongolia. All these countries are trying to implement eHealth enterprise architecture. And in that context, we are involved through AHIN in advising them to hold their hands, to train them in various architectures. Next slide. So why eHealth? I think today most of us are under lockdown. In Sydney, we are under lockdown for the last 6 weeks. So it's a very challenging and trying time for all of us. But we have to step back for a moment, see what are we really facing. Universal health care, UHC, has been a major challenge for most of the countries. Whether it's advanced countries like USA, where there's it has been a very big challenge. It's Australia or UK or developing countries or India, UHealth. That means every citizen getting health care, the right cost, the right quality, and the right reach. That means whether you're in a small village in the corner of India or you are in a small part of Himalayas, you should get the same kind of quality healthcare, same kind of service, at the same cost. It has been an ideal that most countries are trying to reach for the last several decades. To be honest, we can say that no country has reached it. Whether you are a poor country, developing country, or developed country, everyone has got different challenges. Now, this challenge has been persistent for a long time, and nobody has found a perfect solution. You know about Obamacare in the US and the struggle they're going through in terms of adopting it, not adopting it, by going back and forth, a big problem. So, added to this persistent challenge of UHC, COVID-19 has further caused new challenges. What I'm calling as fault lines. It's like earthquake. The earth was itself not stable, but suddenly there's an earthquake. So COVID-19 has got several fault lines in primary healthcare systems in many countries. It affects 3 areas. It affects the people area in terms of professionals, doctors, nurses, and health professionals, mobilizing them, making sure they're available the right place, the right time. A process of how to handle COVID-19 in terms of previous slide, please. A process in terms of how do you handle these different processes related to, for example, mass vaccination or identification or contact tracing, whatever it is, and the technology below that. So there's challenge in all these 3 areas: people, process, and technology. Essentially, we are not here to solve the people problem because we are not in the area of professional doctors, but we are in the area of information. So I would specifically mention lack of right information at the right time and the right location is a major cause for failures in many countries. It's fair to say, without being very critical, in most countries, COVID-19 has been mismanaged. Again, no fault of their own, because they didn't have all the resources in place, the people resources, process resources, and technology resources. So the information challenge has been one of the biggest challenge that has been faced over the last 2 years in the COVID-19 management. The World Health Organization, of course, in the driver's seat, and they know that's a global challenge, and they've been mobilizing funds, and especially for developing countries through World Bank, ADB, Global Fund, etc. We are involved with the WHO in several countries, and funding is one thing, but funding doesn't solve the entire problem. How do you handle the infrastructure problem? How do you handle the information problem? So that's what we're talking about. So that leads us to an architecture. An architecture is needed for actually getting the right information at the right time and the right abstraction to the right people. So robust eHealth enterprise architecture has been the need of the hour in every country. So what does it really mean? It really means how do you actually how do you understand the processes? How do you digitize the processes? How do you visualize these processes using a tool like Sparx EA? And once it is visualized, how do you take proactive decisions? How do you make a what-if analysis? So as we recover from this current catastrophic situation of what I call as the crisis of wealth and well-being, it's a health crisis on one side, an economic crisis on the other side. Now, how do you recover from that? And how do you manage the new normal? Even if everything becomes normal in 2022, it is not going to be the old normal. As everyone is saying, it's a new normal, which means we have to manage the post-COVID era. And thirdly, this is not the end of the pandemic. Every specialist, pandemic specialist in all over the world is predicting that there will be more in the future. So considering all these things, the architectural visualization of the information has become extremely critical. So that's what we are talking about today. Next slide. So in the case of eHealth ecosystem, people talk about these 5 Ps. There is a patient in the middle. All the healthcare systems today are focusing on the patient. The focus previously was on the policymaker or the provider or the money, how much money we pay. But now every healthcare system is trying to put patient right in the middle. The patient, ultimately, how the patient is cared for, how they recover becomes the critical point. The other piece are there's a provider of services, the pharma, the pharmaceutical, there's payers, somebody in the healthcare industry, somebody should pay for it. Who pays for it? Generally, 3 possibilities are 3. One is the individual or the patient himself or herself pays for it, or the insurance pays for it, or the government pays for it. So in many countries, this is again a big tug of war between who pays for a particular service. Is it the public thing like Medicare pays for it, or the medical insurance companies pay for it, or the individual pay for it? So that's another aspect. Then the policymakers, considering all these several aspects, the policymakers have to take decisions just to say, what is the healthcare policy? How do you create healthy citizens? How do you create more healthier citizens out of the current situation, the current state? Next one. Next slide. So objective of today's presentation is this is a big area. It's a very big challenge. We are not trying to address the whole challenge in the next 1 hour. In the health industry, there are many standards already existing. For example, there's Open HIE, and standards like HL7 they exist. So what are we talking for here? If all these standards exist, why are we talking about an architecture? Because we have to bring all these standards under a common architecture framework. So the framework will address everything from top down, right from the capabilities, right from the strategic vision of the organization, of the nation, right up to the solution design, which actually says how exactly are you going to implement the information solutions. While we as enterprise architects from CCNC are involved in many different industries, there are 2 industries which we are focusing on. One is finance and the other one is health. So today is the first attempt where we are trying to bring the best practices from each industry. It's like a cross-pollination. How do you understand, since you understand BIAN, which is the banking industry architecture network very well, and we're actively involved in that. That's an architecture network created by lots of leading banks in the world. So we are learning a lot from that. So we are trying to see how can we apply some of the learnings from BIAN to health industry to create a comprehensive model, an implementable model. It is not a theoretical framework from the ivory tower. It's something for implementation. That's the need of the hour. So I hand over to my colleague Uday, who will take you through the whole process of how do you reach from the top level to the solution level. You as a conceptual framework, as I said, today is not we're not presenting a solution. We're presenting a concept using Sparx EA tool as the medium. Thank you. Uday.
Thank you, Vish. Good day, all of you. This particular concept is actually based on, is using or leveraging the concept of microservice architecture, using the fundamental concept of periodic table, so that at a runtime we can create different systems and methods. We have used Sparx EA tool, modeling tool, to emphasize or depict certain aspects of it, but we also use some example from the COVID so that it can correlate. We are technical experts, so obviously the healthcare nomenclature or something, there will be an issue or there will be a mismatch, but the whole emphasis is how we drill down from top to bottom. So as Vish has already said, there are many frameworks available. So one ISO has already have a e-healthcare architecture model. So if you see in this particular model, they are talking about all the aspects which covers the healthcare system. And then ISO is all about process. It will talk about the process. But then how we are going to reach to each and individual service capability, that again is a question mark. Then comes the second one, which is very popular, that is called Open HIE architecture, which is already available. So if you see on the top blue is the business domain services registries, below is the point of service. And interoperability they have highlighted in green because interoperability is always a challenge. Even within a country, it is a challenge. Even within a doctor and a patient, there is a challenge. Because doctors sometimes use short names, patient understand commercial names, so on and so forth. So there is a lot of communication. So when the information is passing from one point to another, even if multiple people or different stakeholders are using different terminologies, it should match. So that is one of the biggest challenge. Secondly, healthcare system is very, very volatile and very, very dynamic. And due to this volatility and dynamism, we need to have microservices or API-based communication, which can be interlinked together in a very quick fashion so that it can address, because it is going to touch the human lives. So this is a custom architecture landscape. We tried to create one. So on the previous slide, we have taken the stakeholders like provider, pharma, payers, patients. We also say that people are going to interact through mobile, through hospital management, through laboratories. Some logistic also needs to be maintained. Finance is already there. So there is a whole lot of interoperability. And for interoperability, whether we use service-oriented architecture or we use microservice architecture. Service-oriented architecture is slightly monolithic compared to microservice architecture. So flexibility may be a little less, and it is going to impact on the performance. So based on this, we are going to see how we are going to drill down. And obviously at enterprise level, the standards like HL7, FHIR, etc. will always be there. And those who are not aware of in the healthcare system, I have taken this slide from HL7. So many standards are already available and with all corrections and dots. So certain definition and terms, because it will ease out. We are defining something called service domain instead of business domain because healthcare is more towards servicing the people. It is going to help or define the strategic capabilities. Service area, which is operational capability, the standard operating procedure, which is a very common name in healthcare. A service capability is healthcare capability. So healthcare capability can be termed as that this department only provides vaccination. This department only provide RT-PCR test. This department only provide antigen test, like this. And capability is what we talk about in IT terms. It is a package of functionality. So it has attributes, that means parameters or profile information, and it has certain operations also, what we need to do. Then there is another word which is called business scenario. So business scenario is like business process. If you see on the OpenHIE, they have written business process, but process is slightly very you can say, stubborn kind of concept. Business scenario is very dynamic concept, and we will see example of each one. That business object model, this is whole the data structure to which the people are going to communicate. So system is going to communicate with each other. API is application programming interface. This is a very common terms or terminology in IT space. A design pattern. Design pattern is a strategy how the whole thing is going to get implemented. So we are going to focus on all of these one by one. So Sparx EA helped me to also define strategy, but it has multiple facets to it. But just to ease out, I have just chosen vision and mission. An example is COVID. So in COVID, what we want to actually achieve, what is our vision? We want to control the spreading of the pandemic and the community transfer and minimize the human lives, loss of human lives. That is the whole vision. Now for mission, how we are going to achieve it? We are going to achieve it either by tracking, tracing, and treating. So we first identify, we then treat, we check any possibility of spread and then infected person, and then we do all of stuff. So all this what, how, where, who, and when can be created by Sparx EA tool, not only in vision and mission, but we can also elaborate in terms of goals, requirements, assessment, etc., etc. Then we are coming into the segmentation. So as in definition terms, as we have taken service domain, service area, service capability. So I have taken a notation of package because in the definition of term, I said that a package of functionality is called capabilities. So service domain is also a strategic capability. That means whether the central ministry, health ministry, what type of capability they wanted to have, or a hospital, what type of capability they wanted to have. Not all hospital is going to treat each and everything. Some are very specialized, cancer hospital. Or some are like Institute of Medical Sciences, which has almost all the capabilities except a few. Then coming to service area. Service area, you can correlate something like a department or function kind of stuff. Function, I don't want to say department, where they have capacity. So testing is a department. Then your ICU is a department. Then your sample collection, in testing, sample collection can also be department. So that is a service area. That is also a capability of the hospital. Sometimes some hospital doesn't have testing, so they refer to a different testing. And then service capability, that means what capabilities. So in testing, as I said, I am just having antigen testing capability. I don't have RT-PCR, so I will refer something else. So these are the capability, and these are a hierarchy. Why I created a hierarchy? Because it helps if somebody working from the Ministry of Health, then from central government to state government to district level, this can be modeled. If somebody is working just for a hospital, then hospital at a top level, the department level, and under department, what are the capability level? So with the organizational structure, this type of segmentation get aligned. So that is the very first basic thing as an enterprise architect for a healthcare system. By using Sparx, they have to use it. Then they are creating this hierarchy examples. So I have created this example because I have already explained. So the service domain, I have taken data and information. So data and information is very critical. Under data, there is a patient data. And under patient data, at least we have to have profile information. In profile information, UHID plus his name, sex, any other past history of diseases. And then if a sample has gone, then what investigation somebody would like to get, or what type of treatment he is getting. So for a particular scenario, if we see the lowest level of capability for this particular example, we have three capabilities, having the updating the profile information or creating. It totally depends on the situation. Investigating data means what kind of investigation it is going to take and what kind of treatment it is getting provided. Now, further example, if you see on left-hand side, for testing, we have taken the top level is called diagnostic. Under diagnostic, there is a pathology and there is a radiology. In pathology, we normally take about blood, urine, and all those stuff. Radiology is all about X-ray, CT scan. And both of them is going to test and submit some report. But making these things can give an elemental capability. But the whole challenge is how we are going to communicate from one hospital to another, or within one department, or within one between two countries. This profile information, so comes the interoperability. So interoperability is the top. Then under interoperability, standards. Now, some hospitals may follow HL7 standards, some hospitals may follow OHIE standard. Some is just following FHIR, somebody is trying to follow the combination of it. So if you see, there's a red circle where I was trying to just show that, okay, somebody is using mix and match for a interoperability capability. So there is one profile which is coming from HL7, certain information coming from FHIR, and then they are creating a terminology mapping, and they're creating a business capability mapping. This is the biggest challenge in the interoperability space in the healthcare system. Now, this is a representation of business scenario. This is also called sequence flow. And this is a replacement of your business process, which is commonly used in HL7, terminology used in HL7 as well as OpenHIE. Why I am saying this is a replacement? Because in the process, there is always a start and end. It is fixed step. And for creating different scenarios, the process diagram is going to be very complex. But sequence diagram makes it very easy. And here we have just taken a very sample COVID example that, okay, suspect, that means somebody is thinking that he is an infected person. Sample get collected, testing happens, report happens. Based on the report and his condition, either he will be hospitalized or he will be sent to quarantine. And his testing and treatment will keep on working in iteration till the person becomes fine and the hospital and doctor say, yes, now he's clean. So to represent this whole flow, we are using this particular business scenario. Now this can be used even at a first time to capture requirements, or this can be used afterwards after detailing the requirements. And here also we are using the sequence flow section of the Sparx CA2. Then now we coming to the design patterns, and here the whole IT starts. So capability. So as we said in the testing is a capability. Now under testing, there's a functional pattern. So this is a complete abstract design pattern envisaged by CCNC, inspired by Bayan. So we are trying to map attributes and operations together. So if you see on top, we are saying attributes and methods are getting inculcated in functional patterns. Now there is something called generic artifact. Generic artifact is called report, test report is an artifact. And because it is IT system, so it is a digital asset. Auditing also has to happen because of government requirement. Some analytics also need to be required, because if some predictive projection has to be given for any pandemic or any disease per se. Let me take a different example. If somebody is having a patient of CKD, that means chronic kidney disorder, then some analytics is required, because based on his physical condition, the doctor can try to predict that if this parameter is increasing with this rate, how much time it will take before he goes for a transplant or goes for any kind of dialysis. I am not saying that that prediction may be 100% true, but yes, it is an indicative to help the patient how to control and manage himself. Although test reports, prescriptions, everything becomes the digital asset with all the history, which not only belongs to patient, but also needs to be stored in the hospital, so that if he revisits, he will be helped. And then for each and every artifact, there are operations, because now we are just talking about the computers. We are not talking about a human. So we can originate, that means we can create. We can instantiate, that means open a file. We can invoke, and then we can report. So these are the methods. Now in this design pattern, these are all some specialization, generalization, and flow kind of stuff is there. So let us see an example or abstract example for say. So if you see on the left-hand side, so below, functional patterns can be understood in terms of SOP. So a standard operating procedure for any pandemic or any disease, if some standard operating procedure is defined by a hospital or ministry, that can be created as a flow by using the methods given in functional patterns. And some methods are mentioned over here, not all, like advise, allocate, analyze, assess, enroll, etc., etc. Then on right-hand side, there is something called action term. What kind of action we are going to take? The action terms are the action taken under some situation. So it is like that some CKD patient comes in and his condition is not very good. So doctor will advise, okay, cut the vein near the neck. I put him into urgent dialysis kind of stuff. So if we want to record all of these, so we need to create the whole pattern by using this functional pattern and action terms. And here, Sparx helped me to create all the methods, and it can help me also generate a code template in whatever language I want to do. Then coming to more detailed, so if you see functional pattern methods are there, then operations are there, activate, configure, evaluate. So all these methods are there. Attributes I have not mentioned over here because of the terminology mapping. Because attribute may change depending upon who is using what. So that we will handle with a different perspective. But here capability is all about patient, and we are talking about patient profile. So we will see in patient profile what all information will be created. So this is a detailed method-based and operation-based design structure, which is an inclusion of functional pattern and action terms. And because we have all the methods and we have all the attributes, and this is a capability which is elemental, mutually exclusive, and collectively exhaustive. It represents a capability. So it can be envisaged as an application programming API interface, or it can be envisaged as a microservice API or microservices in terms of microservice architecture. Now, if you are going for a microservice architecture, so we have to define the message payload or some definition of the identification of the messages. So it goes like this, that on the top left header will start with the service capability. It could be testing or XYZ. Then there is something called behavior qualifier, which is a precise activity like assess. Now, assess is assessment. So when the doctor sees a patient and he doesn't have any profile information, he first assesses. After assessing, he submits some tests. After test reports, so after the test, the pathology or radiology department notify the doctor. He validates with his experience and then he treats and then he monitors. If patient is getting perfectly fine, it is okay. If not, then he will be kept under monitoring. So these are some minor examples of behavior qualifier set, and this defines how the header is going. Action term we have already defined. So that's how the whole API header is created. We can use the REST protocol, which is very common in IT industry nowadays. So all the message payload will be used for this. So this is the header, and a message payload will be created by after doing this terminology mapping, because I said that the terminology is the biggest challenge. So I got help from some AHIM. These are some data terminology servers which are available. So these are certain suppliers. This is an example of terminology mapping. So this is a Netherlands company, and they are mapping HL7 fire, and they are creating some terminology mapping. So this code 100, 200, 300 may not be relevant, but if you click on every that plus sign, you will exactly understand what they are trying to do. So what we have done so far, we created the whole method, we defined the header, we identified which terminologies mapping server we are going to use, we took the help and mapped the value sets, and now we are trying to identify the attributes. So this is a business object model. Here we are just talking about attributes. Method we have already discussed. So in attributes, I have not taken all the attributes, but certain attributes. So patient has name, national ID, phone number, age, sex. Test result is either positive or negative, or sometimes it is just a number. And normally it says, okay, the doctor has to correlate with the clinical condition. So some impression written by the pathologist. That there is a treatment plan, which is in general term called as prescription. Then there is a location record, and then there is a test type. Test type, I have taken example like name of the test type, so RT-PCR antigen. This is just an example. And these are relationships. So what I am trying to say, now here we got a method, attributes, methods we have already discussed. So these attributes is going to create the message payload, which will be loaded after this header. So if you see on the right hand side, it is written business objects. Now this business objects, what these business objects are? These business objects are the creation either in the form of JSON or XML by these attributes mapped with the or allied with the terminology servers. The relationship will tell you which impacts whom. So this will help you to create the next structure of the JSON, which Sparx very easily help us to do it. Here I have taken this diagram domain model. That's why if you are looking for entity relationship diagram cardinality, it is not appearing. It is just saying which flows from where, because it has taken domain object model kind of stuff. And I have deliberately taken this diagram because domain object model help us in designing the microservice architecture further on. So these are two examples, JSON examples. REST protocol. So I have just taken for the COVID one. So left-hand side represents if I want to identify the location of a patient so that I can see whether he is in quarantine or whatever condition. So that is a snippet of location. It is not a complete one. Complete one is quite big. And the right-hand side is vaccinated, whether the person got first vaccination dose or second dose, or and if he got the both the doses, whether the certificate got issued or not. So these are the message payload. So this is the message payload. This is the header. Now we got the attribute and we got the method. So entire raw material for creating a microservice or API or service-oriented architecture is ready, as least from the design perspective. And here, Sparx here tool is going to help a lot. For message payload, only the values, the terminal values. For that, some additional work is required. Otherwise, as a template, somebody can generate all of these things. So this Sparx ecosystem is going to make it excellent and quite faster to define it. Then comes, after modeling this, we also try to see what are my entry points, which is normally called channels. So as I said, I am using COVID as a reference. So the channels will be airport, railway station, bus stand is the first, school and college campuses is the second channel, mall and shop fronts are the third one, and hospital, labs, private and public. These are the final ones. So these are multiple channels a person can be reported, infected, non-infected, or suspected. But if I don't want to go into this much of detail, we can make a channel into two, manual and digital. And in both manual and digital, it will be personal and referred. Manual means person has walked in, he walked in of its own, or he walked in on a reference by somebody. Somebody means doctor only. Digital means nowadays in COVID, there is a lockdown. So people don't go to the hospital. They simply open a mobile app, take an appointment and transfer all their information. They talk on a video chat and try to get some treatment. And even pathology guys come to your home to collect the samples. So that's why digital channel has becoming more important. And digitization is taking over multiple manual things. So if I arrange the whole thing together, so it's a value chain. So on right-hand side, channel is the important, digital or manual, then the stakeholder. Now, stakeholder, as Vish already mentioned, patient, pharma, provider, payer, etc., etc. Those are the stakeholders at a high level. If we want to drill down even in a smaller one, all those stakeholders will come into picture. Then coming to product. Product could be testing, treatment, operations, mortuary, etc., etc. Then come operation. Now this operation is not related with healthcare operation. This is IT operation. Whether it is 24/7, it is just 10 into, it is 24/5. What kind of operation it is there? So there are countries where certain government hospitals, especially the OPD, they don't work for Saturday, Sunday. Or Sunday is actually closed. And then coming for the support. The support is coming from the pharmacist, support is coming from your financial industry, logistic industry. So there are multiple industry who has to provide supports. Apart from that, everything has to be mapped with the standards, security, regulatory compliances. So privacy policy takes a very big space into this. Then technology development, whether we are going to use open source, we are going to use product, or whether we use JSON REST, or we use SOAP and XML. Human resource management is very, very complex because all the hospital healthcare system is always 24/7, except few exceptions are always there, but it is mostly 24/7. And almost each and every staff, increasing or decreasing number, has to be available wherever this healthcare service is provided. And then coming to hospital infrastructure, and this hospital infrastructure, I am talking about the IT infrastructure, not the hospital infrastructure per se. So this creates a complete value chain. Now, summing it up, so whatever we have discussed so far, so if you see, on top we have stakeholders, provider, payers, patient, policy, pharma. This is one way. You can even break down in terms of departments, or you can break down in terms of level of country. So ministry, then state, then district. Then we have strategic capability, operational capability, and service capability. And this can belong to any of these three stakeholders. Then each service capability, because it is elemental, mutually exclusive, and collectively exhaustive, it represents a functionality, so that, and because it has a methods and attributes both, and with the header, so we can create some APIs. So we will create APIs for all, and then APIs will be supported with the business object model, which is nothing but a database system, which is going to help. Now you have a question, where is the microservice architecture? Now microservice architecture has multiple design patterns. In this example, I have just used one of the design patterns where each microservice is associated with its own data system. So below, if I say API and Bob related, that means I am representing the same microservice architecture design pattern over here. And all this microservice architecture will be deployed on some API container. So that container may be in on-premise or on cloud. And then between the APIs, message will be passed to create the business scenario, what we have envisaged or discussed in the few slides before. So that means we are not passing data directly from one place to another. My data is with me, another data is with them only. Only the message passing is creating the whole process. And this microservice API combination gives a enormous flexibility of creating different business scenarios, business processes, and it helps the healthcare system in many different ways. Now to visualize how it is going to get deployed, so it appears something like this. Below is the infrastructure. Now hospital infrastructure, country infrastructure, or world infrastructure, whatever, in which way we are looking into. On top, if you say there's a cloud, and all the APIs are actually deployed on some cloud container for choreography and or orchestration. And that choreography and orchestration is responsible for creating the business scenarios envisaged as per the healthcare business requirements. And all these message will be passed and the interoperability can be achieved. So it is a three-layer architecture. Top, we will say business with all the hospital information. So here the API message is passing actually at a business layer only. They are not going into this database and all those stuff. So speed is much faster. It is representing the whole microservice concept, and it is actually creating an ecosystem. It is helping to create an ecosystem rather than creating a centralized system, which is somehow very commonly used in wherever the IT implementation is there. Now, when we are creating this kind of architecture, this is a, you can say, template, indicative template, how the design artifacts may look like. So obviously, what the healthcare project description in the scope. We have some business scenarios which tells what are the requirements, then service domain, service area, and capability patterns, and service capability. This topic is going to take good amount of time and detailing so that it becomes elemental, mutually exclusive, and collectively exhaustive. It should have attributes and methods, and those attributes also should get aligned with the other standards like HL7, FHIR, OpenHI, so that there is no confusion when communication is happening through computers. Gap analysis, it totally depends because hospitals may have certain systems available, or the healthcare ecosystem already have certain system available. Something is too customized, something is generic, something is standardized. We need to find out what is the gap, and then we develop a roadmap, and then other aspects of it. So this is the output of the from document per se. This is the output, and if we are using the Sparx ecosystem, then the output will be the code template like this. This is more. Actually, this is written everything, but this will, apart from the actual value, the code template will be generated by this Sparx ES system in your chosen language, which it provides the Ultimate Studio. So that the developer is just going to write some logic or mapping attributes, so he is little less work than writing a code on a notepad or some IDE kind of stuff. So what is the ultimate benefit? So the ultimate benefit is we are getting some good periodic table kind of structure for any healthcare ecosystem, where we deploy microservice architecture by using Sparx EA, so that the dynamism and agility aligned with DevSecOps can be achieved. Thank you.
Yeah, thank you, Uday. Thank you so much for the wonderful session. I'm just seeing the questions panel. So as of now, we haven't received any questions regarding the session. It's all about, they were looking for the recording of this session. So I have answered those questions over there.
Yeah.
Okay, so we haven't received any questions as of now. Yeah. So let's wind down the session over here, and we will continue the discussion in Microsoft Teams. Please make yourself available for a while, just to see if there are any questions popped in. So yeah, thanks once again. Thanks Vish and Uday, and thanks to everyone for your time during the session. Now both the speakers will be available in Microsoft Teams to have a detailed discussions and answer questions in Microsoft Teams. The link to Microsoft Teams is pasted in the chat window for your quick reference. If anyone is having any difficulty in connecting to Teams, please reach us at this chat window. We will be available here for a while, or write to us at registrations@eaglobalsummit.com. Thanks once again, everyone, and looking forward to hosting you all in another informative session at this summit shortly. Thank you, Vish and Uday. Thank you. Thank you for the detailed and elaborative session.